Here, we're going to discuss a discrete probability distribution called the binomial distribution. A binomial distribution can be used to find the probability of a given number of successes in a binomial probability experiment. An experiment is considered a binomial experiment if the following conditions are satisfied. First, there is a fixed number of trials. In each trial, there are exactly two possible outcomes, which we call success and failure. The probability of success must be the same in every trial. And lastly, the trials must be independent. This means that the outcome of one trial cannot influence the outcome of another, and information about the outcome in one trial cannot provide any information about the probability of an outcome in another trial. As we said earlier, the binomial distribution gives the probability of a given number of successes in a binomial probability experiment. If a random variable x has a binomial distribution, we can use the capital letter B to represent the binomial distribution. The parameters of the binomial distribution are x, n, and p, where x is the number of successes, n is the number of trials, and p is the probability of success in any trial. The formula for a binomial probability is n factorial over x factorial times n minus x factorial times p to the x times 1 minus p to the power of n minus x. Let's look at a problem involving binomial probability. Suppose you are playing a game that involves rolling a fair six-sided die and you win if you roll a 5 or a 6. If you play this game 10 times, what is the probability of winning exactly 4 times? For reference, we'll redisplay our binomial probability formula here. In this experiment, the number of successes is x equals 4. The number of trials is n equals 10. Since there is 2 winning rolls out of 6 possible outcomes, the probability of success is p equals 2 over 6 or 1 over 3. Substituting these values into the binomial probability formula, we get b of 4 semicolon 10 comma 1 over 3 is 10 factorial over 4 factorial times 10 minus 4 factorial times 1/3 to the 4th power times 1 minus 1/3 to the power of 10 minus 4. In the first part of this expression, 10 factorial is 10 times 9 times 8 and so on down to 1. And 10 minus 4 factorial is 6 factorial, which is 6 times 5 times 4 and so on down to 1. 6 factorial will cancel everything in 10 factorial from 6 down to 1, leaving 10 times 9 times 8 times 7 in the numerator. In the denominator, we have 4 factorial, which is 4 times 3 times 2 times 1. Moving on and evaluating the next pieces of our expression, we get 1/3 to the 4th is 1 over 81. And 1 minus 1/3 to the 10 minus 4 is equal to 64 over 729. Simplifying this expression, we get an approximate result of 0.2276. Therefore, the probability of winning the game exactly 4 times is 0.2276. Let's go through another example. Suppose you are playing a game that involves rolling a fair six-sided die and you win if you roll a 5 or a 6. If you play this game 4 times, what is the probability of winning fewer than 3 times? Again, we'll display our formula for finding a probability from a binomial distribution here. In this case, we're interested in the probability that our number of successes is fewer than 3, which means we're interested in the probability that x equals 0, 1, or 2. We play the game 4 times, so we have n equals 4. As in our previous example, there are 2 winning rows out of 6 possible outcomes, so the probability of success is P equals 2 over 6 or 1 over 3. To find the probability that the number of successes is fewer than 3, we can find the probabilities of 0, 1, and 2 successes separately and then add those probabilities together. To find the probability of 0 successes, we substitute 0 for x in our formula and get a result of 16 over 81. To find the probability of 1 success, we substitute 1 for x in our formula to get a result of 32 over 81. To find the probability of 2 successes, we substitute 2 for x in our formula and get a result of 24 over 81. Now we can add the probabilities we just calculated to find the probability of winning fewer than 3 times. The probability that x is less than 3 is equal to the probability that x equals 0 plus the probability that x equals 1 plus the probability that x equals 2, which is 16 over 81 plus 32 over 81 plus 24 over 81, which is 72 over 81, which simplifies to 8 over 9. So the probability of winning this game fewer than 3 times is 8 over 9. Let's answer a related question. What is the probability of winning at least 3 times? We can write the probability of winning at least 3 times as P of x is greater than or equal to 3. Using the composite rule, we know that this is equal to 1 minus the probability that x is less than 3. We just found that the probability that x is less than 3 is 8 over 9. So this is equal to 1 minus 8 over 9, which is equal to 1 over 9.